systems.
Hello everyone, and welcome to this session on functional programming with Java. My name is Jacek Kunicki. I'm a software engineer at Software Mill. And at Software Mill, I mostly write Scala code, but I also teach other people Scala, and I teach them functional programming. I used to be a Java developer previously, and when I first came to Scala, there were a couple of things that struck me, because there are some other ways of solving problems that we are used to. And this will be the topic of today's talk. So I want to start with a short disclaimer that all the stuff you see here might seem counterintuitive to you, and this is perfectly fine because you might not be used to this way of solving problems. But trust me, if you spend some more time on doing stuff this way, I'm pretty sure that you would get convinced sooner or later. So let's start with functional programming. And one of the definitions that you can come across when reading about this. So one of the definitions says that functional programming is pure functions and immutable values. And while immutable values are pretty self-explanatory, we'll still get to this later, I want to give a short introduction to what pure functions are actually. So the definition of a pure function is that this is well, you all know what a function is. And a pure function, we can call a function pure when it satisfies two criteria. The first one is that the output of the function only depends on the inputs. So there is nothing from the external world affecting the result of the function. And also, the function has no side effects. And by side effects, we don't understand something that goes wrong, as you might understand this in daily life. But by side effect, we mean some interaction with the outside world. This might be, for example, interacting with the operating system, like printing to the console, interacting with the network, interacting with the hard disk. So anything that requires some I/O, basically, is called a side effect. So let's now look at a function that is actually impure and see what it looks like and what problems can be seen there. So here's a function that takes two parameters. First one is a long, it's a final long, and the second one is some data. This is a data structure that we'll have a look later. And it does a couple of things. So actually, when we try to figure out these problems from the very end to the start, the first thing we see is the last if statement with the system current time millis. And this has two problems which make the function impure. The first one is that it depends on something external, because it depends on a value that changes over time. And also this is some kind of I/O actually, because accessing the system clock is some kind of I/O. So this is not a pure thing, and this changes over time. So this is not a constant thing. The consequence of this being not a constant thing is that it breaks something that we call idempotency, or something very close, which is called referential transparency. Idempotency is a property of a function that when you call it multiple times, the result would also be the same. And for sure, this criteria doesn't stand for this function, because system current time millis will return a different value every time. So it's going to return a different value in the subsequent calls. And referential transparency is a concept which is pretty similar. And this means that you can substitute the function call with the value that it returns. So for example, if we created a function that is called city where Devoxx PL takes place, and then it returns a constant value of Krakow, this function would be referentially transparent. Because whenever you made a call to this function, the city where Devoxx PL takes place, you can also use the value, and you are free to choose whether you call the function or you use the returned value, because it's going to be constant over time. And then we can say that the function is referentially transparent. The next thing that this function does is printing something to the system output. And this is again interacting with some kind of I/O and producing a side effect, because this function not only computes the value somehow, but it also affects the external world. It affects the console. So we are going to have a side effect, which would be something that would be printed to the console. So this is the other thing that makes this function impure. And last but not least, you can see that this function mutates its input argument. So this now has to deal with the immutability and immutable values. The data argument, although it's defined final, is actually not immutable because the data structure itself is immutable. And one way to think about this and why immutability is important is to ask this question whether the data class actually represents some fixed data, some constant value that is the state of the data class, so the values of those fields. And I would say it doesn't, because actually, since it's mutable and since you can change the internal state, it doesn't represent a constant data. It represents the data, the values inside the class, which can change over time, and actually in a quite non-deterministic way, because we never know when a setter would be called and when the internal state would be mutated. And this is something that we actually want to avoid. So let's see how we can avoid this, actually. Let's first see how the data class is implemented. This is something that you are probably very familiar with. It's a plain class implemented in a way that Java Bean standard taught us. So you have two private fields, you have a constructor, and you have getters and setters, and there is some space for equals hashcode to string for some human readable form. And this lets you mutate the internal state of this class by calling the setID or setValue method, for example. So let's see how we can make it better and how we could implement such class in a way that it's immutable. So let's start with two fields. And the first important property of those fields is that they are going to be final. So we have those two fields. The first one is ID. The second one is a value, a string one. Okay, so now we have two final fields. So of course we need some way to initialize them. So we can initialize them in a constructor, and that's great. And of course we need some way to access those fields because we need to get the values. So what you would normally do would be implementing the getters for it. But now the question is whether the getters are really necessary here. How about just making those fields here public? Does it change anything? Does it introduce any problems? I would say no, because the fields are final. So even if they are public, even if they are accessible from the outside, there is still no way to mutate them in any way, provided that the classes itself, the classes of the fields, are immutable, of course. But this is the assumption that we are making here. So I would say you just need the constructor to initialize the class. You don't need the getters, actually. And of course, you don't want the setters, because the fields are final and you want the fields to be immutable. So this is already an immutable class. Of course, we need some more stuff here. We would need equals, hashcode, and some human readable to string. So that if we create a new instance of the class and we want to log it, for example, we don't have the default toString, which is hashcode plus the name of the class, but that we get some readable form, probably with the values. And it turns out that in the modern versions of Java, this problem is solved by a new keyword, a new type of data, which is called a record. And to implement a record like that, like the immutable data, let's call it a data record, we have a new syntax which let us, in this parenthesis here, put the fields that we are going to need for that record. So there will be a long ID and a string value. And that's it. So what we did now was we implemented an immutable class that has two properties, a long ID and a string value. It has a constructor. It is immutable. This is actually final if you look at a final class if you look at the bytecode that is generated. Also, it has a default equals and the default hash code based on the fields that we provided in the constructor, in the parentheses there, and it has a human readable toString method. So let's now see how we can use it. So we just create a new data record with some long value and with some long ID and the value. And that's it. So this is a constructor like any other. And let's print it to the standard output so that we can see whether this actually works. And you can see that indeed we got a human readable toString. We didn't need to do anything, it's just built in. So this is very good. Of course, this is not the most important property of the records. The most important property is that they are immutable, but the readable toString method comes very handy. And also there's one more thing about the immutable data class that we implemented and about the record. And this is the first thing that might blow your mind if you are new to immutable data structures, because it may happen that you actually need to update the value, and what do you do then? And it turns out that you need to create a copy of this class. So in functional programming, when you work with immutable data structures, the way of updating the value is just by creating a new instance of the class. So this may come at a cost, but the immutable approach has a lot of advantages. So I would argue that this is worth the cost. So the main benefit of immutable values is that you can safely pass them around, because you have a guarantee that they are never going to be mutated. So once you create this value, until you create a copy with some updated values, the original value that you created just passes around and it never changes. So this gives you quite a lot of safety. Pure functions, on the other hand, are thread safe, and they can be safely parallelized. This is because they use immutable data. Their output only depends on the input. So this is safe to execute them in parallel, because you don't have any shared mutable state between the executions of those functions. So this lets you safely parallelize without thinking of what might go wrong with multithreading. Pure functions, also given to the property that the output only depends on the inputs, are very suitable for property-based testing. Property-based testing, if you are not familiar with that, is a kind of writing test where you provide some criteria that your function must meet, and then the testing framework generates a lot of test data for you, for all the inputs, and then it knows what the output should be. It automatically covers some edge cases. It actually tries to find those edge cases. So this is very useful, and this is very easily done when you are using pure functions. And also, last but not least, if you ever heard about functional programming, you might have heard this buzzword that functional code is easier to reason about. And I agree that this is a buzzword because you hear it everywhere. But on the other hand, it makes a lot of sense, especially given the properties that we just went through. Because there are a lot of advantages of this approach. And if you read the code, and if you see a function, if you know that the function's output is only based on the input, then it's actually easy to reason about this function, the entire code that is then built up of those functions. So it is a buzzword, but I would say there is a grain of truth there. Okay, so this was a quick introduction to what functional programming is, what pure functions and immutable values are, and why are those important. So let's now jump to a topic that you are probably dealing with every day, which is error handling, and how to approach error handling in a functional way. So let's start with a service that has some way to find the user by ID. And what it does now is returning an optional of a user, which means that the user might be there or might not, which is quite reasonable. And then we have the usage of this service in some kind of API. Judging by the names here, you might assume that this is some kind of HTTP API because there is some response, but this doesn't really matter. The only thing you know about need to know about the response is that it could be either OK or some kind of not found, some kind of server error. So now we are calling this function that that gets the user by ID and returns an optional. And now looking at the code, there's a couple of questions that arise. So the first one is, can you tell by just looking at this function whether something might go wrong when it's executed? Can you tell whether it's going to return some expected errors? Because of course something might fail unexpectedly, the network connection, the network might be down, the database might be down, but very often you have some kind of errors in your application. You can call them business errors, domain errors, anything like that. And those are kind of expected errors which you expect to happen. So I would say by just looking at the signature, you can only tell that the user can be retrieved or it might not exist, but nothing more. So then what happens to the errors? If an error occurs, Do we know if an exception occurs? Because this is what we would expect, that an exception would be thrown. Do you know what's happening to them? If you are using some kind of framework that has a catch-all exception handler at the very end of the call stack, then probably this would be handled there. And if you add your errors there, they would be presented nicely to the user instead of giving this internal server error page with no details at all and a stack trace. Also, if you used exceptions for that, you would be able to tell whether you handled everything, every kind of exception. So this is very useful. But the question is, and this is the goal at which I'm aiming, are exceptions actually good for that? So this might seem unrelated, but do you think that go-to statements are good? And are go-to statements good for controlling the flow of your program? Probably you know, and you've heard a lot of it, that they are not good because they make the code not easy to reason about, actually, because you might randomly end up in a very different place in your code base, and the control flow is brought to a completely different place. Does it have anything to do with error handling? Well, it does, because if you think about exceptions carefully, exceptions are actually a way of creating a go-to statement. This is they work in a quite similar way. So they jump you to a very, very different place of code, in the code probably, where the exception is handled. And the other drawback of exceptions is that throwing an exception is one of the most expensive operations that you can do on the JVM. So we were talking about those pure functions and those immutable values. So actually, what is going to happen, what would happen if we decided to use normal values, so normal classes that represent some values to represent our errors, the expected ones, of course. I would say this has one main advantage, which is unification. It unifies, it gives you a unified way of handling the return value of your function. Because if you use exceptions for a function, then in case of our find user by ID, you have the optional type which represents a successful value. But then for an unsuccessful value, you have a completely different way of handling it, because this is not a value that the function returns, this is an exception that is thrown. So this is a completely different mechanism, and it has this drawback that it's not unified. I'm also not saying that you should drop exceptions completely, because that's not true, of course. I'm saying that we could try to model the expected errors, the business or domain ones, with values, but of course we need to still leave exceptions for the truly exceptional cases, when the database is down, when the network is down, and then this is still reasonable to have a good catch-all exception handler somewhere in your code that is going to deal with those truly unexpected cases. So let's try to figure out how we could modify our code so that we handle errors this way. And for this, we are going to implement a data type specifically for this purpose. This data type will be called OR, and it's going to have two generic types and actually two possible values, the left value, the L, and the R value, the right. And by convention, the right value, as right in English means something that is on the right, but also something that is right, which means correct. So we would, by convention, we would use the right value for the successful output of a function, and we would use the left value for the unsuccessful invocation, so for the case where an error occurred. We already know about records, so we want the kind of immutable data structures to represent our errors that inherit from this interface that implement it. So we are going to implement those. They are going to be generic with left and right, and the left value is going to have a value of type L, and it's going to implement the OR interface of L and R. And similarly, we're going to have the type to represent the right value. It's going to be called right, and the difference is that the value here is of type R. So the right is going to represent the correct value, the left is going to implement the error. So now let's think what actually we want to have on the left side when something goes wrong. Well, your initial idea might be to just put an exception here, because, well, we have exceptions for error handling. But do you really need an exception? Do you really need anything from the exception hierarchy to be here? I would say no. I'd say that we can have our own error class, a structure similar to this, an interface with some immutable implementations that would be used for just handling the errors. So we have an error interface, and let's going to add a single implementation here for now. It would be called a domain error because we want to indicate that those are domain or expected errors that we are going to handle this way. And it's going to have some kind of a message, and it's going to implement the error interface. And now let's jump back to our service where we implemented the find user by ID. And let's try to implement a better version of find user by ID. It's not this one, sorry. So it's going to return an OR now. So this is the new type that we implemented. On the left side, we want to have something from our error hierarchy. I need to take care not to confuse the imports with the Java lang error. Okay, that's it. And on the right side, nothing changes, so we still have the optional of user here. And it's going to be better, of course, so let's call it better find user by ID. We get the long ID. And we are going to return something here. Our service is dummy, so we are just going to return some random failure because, yeah, that's what we want to do here. So it's going to return a new left because it's going to be our left value. It's new or left with a domain error with some kind of error message. So this is how we implement our service, and then let's go back to the API, so to the consumer of this service, and see what happens there. So here we are calling the method once again. So we are saying that we are using the service, and then calling better find user by ID, and passing the ID. We want to assign it to a value. A final one, because we are already in the immutable world, so we were starting to use the final keyword where possible. And now we want to do something with it. And here, what comes to help is the old new mechanism in Java, which is a switch expression, or actually now a switch statement. But it turns out that in the most recent versions of Java, it is much more powerful than it used to be. Because what you can do, you can now switch over the user that was returned here. And this looks like a switch that you are used to, but there are some new features when it comes to the case statements. Because now, previously in the switch statement, you could only match on some fixed values, on some constants. Now, in the recent versions of Java, you can match on types. So, for example, what we can do here is we can put an OR right, with anything on the left side, because we don't care about it, and we have an optional of user here. And we can already assign it to a value. So now the value of R that we have here is the right variant of our OR that was matched against when switching over the user. And now we can have a block of code here that does something with the right. So actually, we want to take the R value, which is the optional of user. And what we want to do something similar that we did before. So we just want to map it to the response. So whenever the option was defined, we want to map it to response OK. When it was a failure, we want to map to response not found. And we have a couple of warnings here. Well, it says that the result of optional is ignored. Indeed it is, because we are not returning it anywhere. So normally what you would do in that traditional switch statement would be putting a returns keyword here. But actually, the new switch statement is not a statement anymore. It is an expression. And this means that it has a value. So we can do something like here. And the output, the result of calculating the switch expression is a value that you can use. So you can assign it somewhere, and you can directly return it. So now we covered the right-hand side of our OR. So of course we have the other variants. So we also need to cover the left-hand side. And then this is OR.left. And we have an error here. And then we have anything on the right, because now it was matched as a left. And now we are going to expand it in a second, but now let's just assume that we are going to return some kind of server error with any message. Now we can still see a compilation error here around the user. And expectedly or unexpectedly, the compiler knows or tells us that we haven't covered all the variants of our OR. But we did. We know that there is the right variant and the left variant, so why does the compiler complain? Well, there are two ways of solving it. The most intuitive but incorrect way would be to put a default clause here and do anything. I'm just putting null here so that it compiles. And now the compiler is happy. It doesn't complain anymore. But this is not the way you can do it. It turns out that if we go back to our OR interface, there is a new keyword in new Java versions called sealed, which means that we are sealing the hierarchy of the OR. So we are telling that all the possible implementations are here in this file, in this case. There are some other variants of that, we'll see them shortly. But for now, it says that this implementation is sealed so that the compiler knows what the possible options are. And now when we go back to our API, you can see that the compiler error is gone, because now the compiler knows, because of the sealed keyword that we used, that we have actually covered all the versions. And this answers the issue that we had previously, whether we know if we handled all the possible errors from our hierarchy. It would be doable using exceptions, but it's also doable using those sealed hierarchies, as we see here. And of course, we also might want to match on something that was inside the error. So in the current preview of the switch statements, you need to match again on the l.value. So you need to put another switch here and put l.value, and then you need to have another case statements. So the first one would be a domain error. It's domain error with would be E. And it would be response server error of E.message. So now the compiler complains again. Let's see why. And we are already familiar with this error message. It tells us that we didn't cover everything from the domain hierarchy. So, well, we have a domain error here, and it seems to be the only implementation. But actually, it's not, because if you look here, you notice that we have something new, something that is an external error. And this is defined outside of the file. Well, but of course, we already know how to solve this. We add the sealed keyword, and we're done. Except that we are not, because now the compiler says something else, and it says that the sealed class permits clause must contain all subclasses. So what's the permits clause? And actually, this is another addition to the sealed hierarchies. So whenever you want to build a hierarchy that is a sealed hierarchy that is defined in a couple of files, you need to use the permits clause, and IntelliJ would be happy to generate this for us. So now we say that the error hierarchy is sealed, so it has a limited set of implementations, so that the compiler knows what the possible variants are. But also, since one of the implementation is defined in an external file, you need to use the permits keyword to list all the actual implementations. So one of them is the implementation here that we have locally, but the other one is the external error that is defined externally. So going back to our API, of course, we also need a case for the external error. And well, this could be the same. This doesn't really matter. Of course, in the real application, you might have different error messages for different kinds of errors. Here, for the sake of simplicity, I'm just using the e.message. And you can and now you can see that the compiler is happy because the Scala compiler calls such kind of match exhaustive. So this means that all the possibilities were covered. So this match is exhaustive because we have covered everything. There is one more nice thing that you can do with inside this pattern matching. You might have some specific criteria for this domain error. For example, that, I don't know, the error message starts with E. And normally what you would do would be putting an if statement after the arrow, but with the new pattern matching, you can do something like that, and you can just say that e.message starts with E, for example. And that's it. Of course, the rules that apply here are similar to the rules that apply to the normal, like the plain old switch statement. Now it's an expression, so that you need to start with the more specific ones and then go through the more general ones. Because if I did something like that, the compiler would tell you that the code here is unreachable, because the previous case block is more general, and this one would never match. So you still need to remember about the correct order. The more specific cases come first. So that's how we handled errors in a functional way without using the exceptions. We actually created our own type, which represents the errors, the expected ones, as values. And now if you look at the signature of the function, the better find user by ID, you can clearly see that that an error can happen here. And actually then by looking at this sealed hierarchy here, you have the full information of what kind of errors can happen. And this doesn't include throwing any exceptions at all, which saves you a lot, probably. So by now we've seen records and we've seen those sealed hierarchies. And this is the first place where I want to talk about some more general terms, because it turns out that they are like concepts implemented this way in Java, but those are actually some more mathematical concepts. And they are called algebraic data types. And algebraic data type is a type that is formed by combining other types. And we have already seen two of those here. We have seen the record, which in the terms of algebraic data types is called a product type or a Cartesian product type. Because the state space of this type, the possible values are the Cartesian product or all the components. The other one that we saw, the sealed hierarchy, so a sealed interface with implementations, is called a sum type, or you can also find it by the name of a disjoint union or a co-product. So the co-prefix is very, very common in functional programming, because this is some kind of a complement of something. So here you have a product type, and you have the sum type, which is a complement of that, and that's why you can call it a co-product. In other words, you can think of those types as aggregation, as in the record, versus choice, as in the sealed hierarchy. So the record tells you that all the fields are present at the same time, because this is the Cartesian product. The sealed hierarchy or the sum type tells you that this is a choice. So you can actually choose one of those values, but not more than one of them. What this helps with is representing valid states in your application, because if you use hierarchies like that with sealed interfaces and with record types, then it's very easy to make all the illegal states unrepresentable, because you have a full list of what's possible, and anything of this list is not possible, and you have it clearly defined in your type system. So you have like a compiled time guarantee that all the valid states are represented and all the invalid states are not represented, and there is no way to actually represent an invalid state. So this was about error handling and about algebraic data types, one of the first generalization. So now let's talk about validation, which is another thing that you are probably coming across very often. So let's see how can we approach validation in terms of how we return the errors. So here we have a person record as a simple one. We have some common validation logic. We are validating the name somehow. We are validating the age somehow. That's really not important what's here. And we want to implement two validators. Here I'm not going to use my own types anymore. I'm going to use the waiver library. I was not sure how to pronounce it, but it turns out that someone put a correct pronunciation on SoundCloud, and it's waiver. So this is the library. Waiver brings a lot of functional programming data types and building blocks into Java, so it's a very nice one. So with this first approach, with this validator, we are going to use the either data type. And either is very similar, or it's actually the same as the or that we just implemented. Of course, it has much more methods, but the concept is the same. So you have two values, the left side and the right side. The left one is the error, the right side is the correct one. So in our case, the error message would just be string, because we are going simple there, no own hierarchy, just strings. And when we validate the name, the correct return value would also be a string. So in terms of when we do validation, the incorrect value, the error is an error message, and the right value, the correct one, is the actual value if it was valid. So we can call it validate name, we put the name here, and the logic is of course pretty straightforward because we have the isNameValid method, and if it's valid, we return the right side of the IDER with the name. Otherwise, sorry, question mark here, of course. Otherwise, we return the left side of the IDER with anything, let's call it invalid name. And we need a return, of course. Yeah. So this is how we validate the name. Then we validate the age in a similar way with an IDER. And then we want to combine those two, because our use case is that, for example, someone fills a form on your front end, on the web page, then submits the data. We want to validate it, and then we want to return the errors. We are going to create a validate method that takes a name and that takes an age. For now, it returns void, and this is on purpose. Of course, eventually it's going to return some kind of value. And what we can do here with the IDER, well, we can first validate the name. And then we want to validate if the name was valid, or maybe not, but now we assume that the name is valid. And if the name was valid, we want to validate the age. The age validation logic, again, returns an IDER. So what we want to do here is to use the flatMap method, which takes the value of the first IDER, then calls another function that also returns an IDER, and then you are able to flatten, because then you would get an IDER of an IDER, and flatMap lets you combine those values and flatten them and have a single IDER as the returned value. So here we have the name. With the name, we want to validate the age, actually. So validate age, and we take the age from here. And then having the age, so having n as the valid name, then having the a as a valid age in the map method, we want to combine those two in a new person record, because this is what we want to return. So here we return a new person of n and a. Okay, so the compiler thinks I'm not going to return anything, but I am actually. Okay, what happened here once again? So we did the flat map, we did the map. Oh, we don't need the return here. Sorry, this is a map, so sorry for that. So this is NA. Yeah. And now, of course, we want to return it to see what the actual type is going to be. So now the compiler helps us, and we can see that the return type is an either of a string and a person. So the person on the right is fine, but what happens with the error messages? So it turns out that although it can happen that we had two validation errors because both the name and the age could be invalid, we would still get a single string here, because we are getting only a single message here. And this is caused by the fail fast behavior of the flatMap method. So whenever you have a chain of flatMap methods and then a map method at the very end, the behavior is fail fast. So whenever it encounters an error, it's going to return it and stop processing further. So if the name is invalid here, we are not going to validate the age at all. And in a scenario where we validate a form, this is really not desired, because if a user submits a form and they have made a couple of mistakes, then probably we want to display all the mistakes at once. So we don't want to validate a single field and then the user only gets a single error message, but then it turns out all the subsequent fields are wrong as well. Because this is not nice from the UX perspective. We want to have all the errors at once. So it turns out that using an either for validation might not be a good choice because of this fail fast behavior and because of the fact that you are only going to get the first error. So let's see if and how we can approach this in a better way. So we are still going to use waiver for that, but we are going to change the type. So now we are not using either, but we are using another type from waiver, which is called validation, which is quite similar to either in terms that it has two sides. It has the valid and the invalid side, or the right one and the left one. Other than that, it behaves quite similarly, because in these methods, the only thing we need to change is actually use validation valid instead of either right, and validation invalid instead of either left. So that's it. Now we want to implement the age validation in a similar fashion. And still no surprise here, so we are doing the same, just using validation instead of either. And now comes the funny moment when we want to combine everything. So again, we have this public validate method. Let's just take the signature from here. And it's going to be void for now. And now, since the fail-fast behavior was not desired, you might expect that the behavior of validation would be something that we actually desire, which means it's going to accumulate the errors somehow. And indeed, it's going to do it. So we use a combine method in the validation class to combine and yeah, there is a lot of auto-completion here, which is going to combine the two validations. So we're going to validate the name here. And we are also going to validate the age. And this gives us some builder type, which actually says that we can get some kind of error as a string, and we can get a pair of string and integer, and the last string and integer is actually the age, the name, and the age that we are going to use to create a person. And to build the person from that, whenever all the values were valid, we use a magic AP method on the validation. And by looking at the signature, you can see that it needs a function that takes a string and the integer to build the person, because this is what we want to return if the validation succeeded. So fortunately, we have a function that takes a string and an int and builds a person out of that. And this is the constructor of the person class. So we can pass the constructor here, and it's going to return us a person. In our API, let's say that we still want to use the either type to return it externally, so that because for some reason we might want to use an either there. This is not necessary, but let's just see what happens. And of course, we add a return statement here. And we need to adjust the type. So what happened? If you look at the either here, you can see that previously when we used either for validation, we only had a string here. But now when we use the validation class for validation, we have a sequence of strings here. And sequence is some collection type from waiver. You can actually adjust it to just be a Java list. So you can take sequence as Java and use the map error on the validation, which is used to do something with the left side or with the invalid side. And now you can see that this is already a familiar type. This is a Java util list. But still, you have a number of error messages here. So the benefit of using the validation type instead of either is that it doesn't have a fail-fast behavior. It executes all the validations. When all the validations are successful, it's going to use the constructor provided here to build a valid person object. Otherwise, it's going to give you all the errors. And this is very useful for when you want to return it to your frontend, for example. So this is how we would do it. So it turns out that the two approaches to validation, the either and the validation that we just covered, can also be generalized to some functional programming terms. So this is another place where some maths and some generalizations come into play. It turns out that the either type is something that we call the monad. If you haven't heard about it, well, it's quite a complex concept, but for now, the important properties of a monad here in our validation example is that, first of all, it lets you sequence dependent computations, which means computations where the next computation depends on the result of the previous one. And we saw it in the flat map method here, because we use the validation of the result of validating the name, and then we chained it with the validation of the age, and then we created a person out of that. But a monad, the property of a monad is that it imposes a fail-fast behavior. So whenever an operation fails, the rest of the chain of the operations is not executed. So this is the important property. The validation type, on the other hand, is something that we call an applicative or an applicative functor. And this behaves differently to a monad because an applicative, first of all, lets you run your computations independently. So you notice in our example that the validations would be executed independently of each other. And the other important property, contrary to a monad, which has a fail-fast behavior, is the accumulation of the results. So it doesn't fail fast. Even if any validation fails on the way, it's going to accumulate the results. So it's going to give you all the errors in this case. So a monad and an applicative. Monads fail fast, applicatives accumulate the values. So this was about the functional programming stuff that we can see. If you read the abstract, there was also something about the framework-less dependency injection. So this might be unpopular or controversial, but I'm going to show you one example of building an application. So normally in the Java world, probably a lot of you use Spring or some other frameworks to help you build the application. So a normal application would usually look something like that. So you would have the Spring Boot application annotation, then you would have the Spring application run, and this is going to be the entry point of your application. But how about just doing this manually? So I have some kind of application class that has a start method, and I'm going this manually. I'm going to do this manually. I'm not using any framework here. And now looking at the start method, what it actually does, this is, I would say, a typical scenario of what you can do. You need to load some configuration. You need to create a connection pool for the database. You need to create some of the layers of your application, so a repository, a service, some kind of API, and then you want to start it. And of course, you can do it with a framework, but is there anything bad in doing this manually? I mean, when you go to the Scala world, where you do Scala, we don't actually use frameworks like Spring, for example, for setting up our applications. We just do it manually like that. There are some frameworks for dependency injection in Scala, but they are mostly compiler macros to call the new function, the constructor for you. Here we are calling the constructors manually, and I would argue that there isn't anything bad in calling a constructor manually. You really don't need to fear the new keyword because there is nothing bad in doing that. So when you use frameworks for do this stuff for you, the question, and I'm not saying you shouldn't do it, but it's rather food for thought for you. Isn't this over-engineering? Like, do you always need the complexities of Spring Framework, the kind of magic that happens behind, all the proxies that are created? Do you really need it? Is there anything bad in doing this manually? I would say no. And the other thing, which was described in a blog post and in a talk by Adam Warski, is something called programming with annotations. And Adam created a hypothesis that when you do annotations, that annotations are actually another language in a language, and annotations are a language that is interpreted by your container, so by the Spring Framework, for example. So then instead of using a familiar language like Java, for example, to do all the setup, all the wiring of the dependencies, as I showed in my example, you're actually using another language in the form of annotation which is then interpreted by some kind of container like Spring Framework. And whether this is good or not, well, I think it's a great question. So there will be a link to the blog at the end. I really encourage you to read it. So there's a couple of things I'd like you to remember from this talk. First of all is try to think in pure functions and immutable values. So this can be mind-blowing. This might be and probably would be counterintuitive at first, but it really can help to solve a lot of problems. And if you get used to it, it becomes very natural. So for me, and it takes time. So it took a lot of time for me to become familiar with it and to think in this style, but it's really useful. Think if you actually need exceptions for controlling the flow of your application whenever an error happens. Consider whether it's not better to use values for representing errors, which give you, first of all, a clear description of what might go wrong. The function signature tells you that something might go wrong. Also, you have a unified way of the function returning a value, whether it's successful or not. So you don't have two different paths, two different ways of dealing with successful values and with errors. I think it's very useful to use the new features with in the form of this algebraic data types, the records and the sealed hierarchies. When you combine them, you need to remember that this is still a preview. If you want to use it, you need to use the enable preview flag. But it's already extended in Java 19, and there are some new nice features to the pattern matching. So probably it's going to stay there, and I think it's going to be stable sooner or later. Then the concepts from maths and from the functional programming don't really bite. So you just learned about monads and applicative functors, and although the mathematical abstractions might be complicated, the core properties of those constructs are really easy to understand and very useful. Also, there is life beyond the Spring Boot application. So here is the link to the blog post. The link to this repository would be online. I will give you a link later, so you don't need to write it down now. This is the case against annotations block entry, and I really recommend to read it. And last one, if you were to read a single book about functional programming, I truly recommend the Functional Programming Simplified by Alvin Alexander. If you have never touched functional programming, I think this book would be nice. If you have touched it before, it might be too obvious because he's creating some very big analogies to different stuff. But I think if you never heard about these concepts, it's really good piece to read. Okay, so that's all I had for today. Thank you very much for your attention. If you have any questions, you can catch me here for a couple of minutes. Unfortunately, I need to leave shortly. So this is the link to the repository. All the talk class is there, so you can take the slides from there as well. Thank you.